Hello there, and then welcome to a brand new lesson. This is Half Beyond Numbers, where we learn maths the easy way. Now, in our previous lesson, we learned about the various regions of the three-set Venn diagram. This time around, we want to look at the formula that governs all our workings with respect to the three-set problems. So, without much ado, let's quickly look into it. Okay, so now I'm teaching this with the assumption that you have gone through the previous lesson and you understand all the names of these regions. With that in mind, we said that the union is the sum of everything, or let me say the universal set is everything inside the box. You see, and then if you look at it carefully, you realize that the cardinality, so the n of u, is equal to everything you have in A. You see, so everything we have in A and then B and then C all together, plus this side here, which is actually our complement. So you see the universal set is A union B union C plus the complement. You see, that is if there was an element in the complement over here. But if we don't have any element in the complement, then we can simply say that our universal set is equal to what? The union of A, union B, union C. Now, with that in mind, how do we find A, union B, union C? So for A, union B, union C, I'm going to give the formula we need, right? And I would say you should pay attention to it. Pay attention to it so that you'll be able to understand. It's just a procedure. If you get it now, you'll be able to apply it in any three sets problem. So first of all, we want to add what we actually have as A, B, and C. You see, so the total of everything. You see, you include all the singles. And how do we write that? It is going to be all of A plus all of B, then plus all of what? Your C. Now, after adding all of this, the next thing we do is to subtract the intersections. So by intersection, you see this portion over here. We are talking of A intersection B. You see, so minus A intersection B minus, so B intersection C as well. So you have B intersection C. And then finally, this portion over here, which is A intersection C. And that is what you have over here. Now, after taking out the intersection of the two sets, then you now add the intersection of the three sets. You add the intersection of the three sets. So plus A intersection B intersection C. You see, so what does the formula says? It says add all in A, all in B, all in C. Then you take out what you have in the intersection of A and B. Take out what you have in the intersection of B and C. Take out what you have in the intersection of A and C. And then you now add what you have as the intersection of the three sets. This is the basic formula we need to solve three-set problem. If your universal set is equal to the union, then you can see all of this here is equal to your universal set. That is all you have in your box. But if that is not the case and you have the complement, then all you need to do is to also add the complement over here. That is if it is not equal to 0. So with this said, let's take some questions and see how we can apply this formula. So looking at our first question here, it says a survey was conducted on 100 tourists. Okay. Now, we know using our notation, 100 tourists is going to be n of u, that is the universal set equals 100, regarding which country they had visited. So we have Ghana, Nigeria, or Benin. 5 visited all 3. So that is your J for Ghana, N for Nigeria, and then B for Benin. J intersection N intersection B. 12 visited Ghana and Nigeria, 10 visited Nigeria and Benin, 8 visited Ghana and Benin, 30 visited Ghana, 25 visited Nigeria, and then 20 visited Benin. The first thing we have to do is to represent this information on a Venn diagram. So let's look at how we can work this out. If you finish, then we approach the calculation aspect. So this here is going to be my Venn diagram I'm going to use. And let's start our labeling. So first of all, we're told that the universal set is what? 100. The universal set is 100. So I'll come here and then come and put it there that yes, my universal set is 100. Now, we know that 5 visited all 3. Okay. Now, with the 5 visiting all 3, what do? We will have to indicate. Before we put anything in there, at least since we have this information, that is what Ghana represents, what Nigeria represents, and what Benin represents, let's put them outside here so that it will guide us. So I'll put here what we have for what? Ghana, which is 30. Okay, so I'm putting 30 for, and then I'll come all the way here and then put what we have for what? Nigeria. You see, so Nigeria for 25, and then I'll put that of Benin over here as well. So with this done, we now, to fill our Venn diagram, it is the best practice is to start from the middle. Start from the middle. So if you come here, they said 5 visited all 3. All 3 represent what you have in the middle. The middle, this portion is the middle. So I'm going to put my 5 there. Then 12 visited Ghana and Nigeria. 12 visited Ghana and Nigeria. Which portion represents Ghana and Nigeria? So if you look at it carefully, this is Ghana. The whole of this red is Ghana. The whole of this blue is Nigeria. So if you are talking of Ghana and Nigeria, then we mean this whole portion over here. But in this whole portion, we already have 5. So we need something here to complement it so that they all have what? They all sum up to 12. You see? So this portion is going to be 12 minus 5, which is what? 7. So we put that 7 over there. If we continue, we have been told that 10 visited Nigeria and Benin. All this blue is Nigeria, and then all this black is Benin. The intersection is these 2 portions we have here. But we already have 5 here. So the remaining is going to be what? 5. So that 5 plus 5 gives us what? 10. You see? And this portion here all together is the Nigeria and Benin. We are taking this idea from the 2-set problem. Okay, that is what we are applying here. Now you also have 8 visiting Ghana and Benin. So all this circle here is your Ghana, and then this is your Benin. Now, if all this portion here represents what? 8, and you already have 5 here, then you'll be left with just 3 here, which you'd put over there. Now, we have all the information on the Venn diagram. But don't forget, we don't have this portion, neither do we have this portion, no, this portion as well. But you will not be asked to find them. Meanwhile, you need to put them there. Or on the other hand, you have to put them there. The reason being that you've already been given what this whole red circle represents. You are told it is 30. So if it is 30 and you have 7, 5, and then 3 here, what do we have remaining over here? So we have 7 plus 5, which gives us what? 12. 12 plus 13 gives us 15. Meanwhile, we want all to be 30. So we subtract the 15 from our answer, and then that gives us what? The 15. Then we come here as well. So we know this blue circle, everything is supposed to give us 25. But we already have 7, 5, and then 5. If we add them all together, what does it give us? So we have a 17. You see? So if you subtract our 17 from the 5, that is going to give us what? An 8. Then we write the 8 also over here. Gradually, our Venn diagram is taking shape. So we have all these over here, with which have to sum up to 20. But we have 5, 5, and 3. 5 plus 5 plus 3 gives us a 13. 20 minus 13 gives us what? And a 7. And that is what we have over here. So with this, we have been able to fill out our Venn diagram. Now, we weren't told whether or not there is a complement, but we will have to confirm, because we're given the universal set to be 100. So if there is no complement, then at the end of the day, if we sum up everything in here, we should get 100. You see? So it's up to us to confirm. Why do we need to confirm? You need to do that so that you'll be able to determine if the complement has an element or not, because that also affects how you write your formula. So as I'm saying, we should add everything in here and then see if it will actually give us this 100. All right. So we have 15 plus 7 plus 8 plus 3 plus 5 plus 5 plus 7. If you have to add all of this, you are going to get a 50. You see, and 50 is not what we have here. So it means there are some tourists that have not visited all these three, or at least one of these three. Hence, we need to indicate that here. So if everything in the box, that is the total number of individuals or tourists that were interviewed, is actually 100, and then we have only 50 within our set, then it means the remaining 50 are going to be outside here. So I'll write that with green and then put it here. With this said, we can now go on and see if there are more questions to be solved. Now, these are the continuing questions we will need to address. So first of all, how many visited J only? That is I. And then N only, that is Nigeria only. And then the third one, B only. If you look straight at the Venn diagram, you realize that we have already solved all of those, right? But over here, I'll give you the formula you would need to present your answer well. Okay. So for G only, that is G only. I'll give you that for G only, and then you can look on that and do the preceding ones. So for G only in English is actually written as G only. But if you want to write it with the notations, that is G intersection N prime intersection your B prime. So it is equal to all of J over here. So all of J. And then we took out this 7. You see? So we take out this 7. And this portion is what is inside J and then in N, but not in B. Remember when we're doing the representation of all the regions. So this 7 is written as what? Minus. So it is in J and in N, but not in what? Your B. That is this 7 portion. After which we also removed this portion over here. So minus, it is in J and in B, but not in what? N. And what else do you think we removed? We removed the intersection of all the sets. That is this 5 over here. So minus your what? J intersection B intersection what? N. So writing it, all we are saying is your J only, which we actually want, is given as your 30 minus 7 minus 3 minus 5. And that gave us our 15, which you see over here. You see? So based on this principle, you can also follow as well and get that of N only, which was 8. So let me write that here. That was 8. And then J only was 15. And finally, your B only was also 7. With that said, let's look at the next question. It says, how many tourists visited at least one of the 3 countries? At least one of the 3 countries. Now, it is important you understand the terminologies of this topic. When we say at least one, what they mean is the union of everything. You see, so at least one could be one only. At least one could be including 2 only, and then it also be what? All the 3. That is at least one. So ranging from 1, 2, and then all the 3 sets. Okay. So how do we get the at least one? Now, at least one's formula is actually what I introduced to you over here. This, all of this over here. That is the union of our set. But since we have been able to write out everything in the Venn diagram so nicely, look at how simple it can also be. So our universal set is then going to be what? So we can add the 15. Let's first of all add the 15 to the 7 and then to the 8. So we are adding all of this. It says at least one. So let's add the ones, and then we come and add the 2's. You see, so plus 7, 5, and then your 3. So 7 plus 5 plus your 3. And then finally we add the 5. So plus 5. And that gives us a 50. You see. So we conclude by saying, okay, 50 people visited at least one of the countries. 50 tourists visited at least one of the countries. So looking at our last question, it says, how many tourists visited none of the 3 countries? It is actually talking of this portion over here, which we've already addressed as 50, you see. But if you want to apply the formula, it is talking of the complement of it all. And if you remember, we said the universal set is equal to, so it is equal to the union of all the sets plus the complement of this union we are talking about. You see, so doing our necessary substitutions, we know the universal set was 100. So 100 is equal to, and then we were able to find the universal set over here as 50. So it's equal to 50 plus the complement, which we do not know and we want to solve. So I'll just put that over here. This is the complement over here, you see. So now making this the subject, we are going to say 100 minus 50 is equal to what we are solving, you see. And then making that the subject, it simply means our complement is equal to what? 100 minus 50, which is a 50. So it simply means that 50 tourists visited none of these 3 countries, and it's as simple as that. This is just a sample of how we solve 3-set problems. I would put emphasis on the fact that if you are able to understand the various portions and know your formula, it is easy going. So if you have not gone through the previous lesson explaining each and every portion, I would advise you do that once again just to make it stick. And then you come back here again. We'll solve more examples in our subsequent lessons. But as usual, I'll leave some exercise so that you try on your own. So here is just one question you can try. It says, in a survey of 50 students, 20 like apple, 25 like banana, 15 like citrus, 5 like A and then B, 4 like B and C, 3 like A, and then 1 likes all 3. So you take note of all this. How many students like apple and banana only? How many students like banana only? What is the total number of students who like at least one fruit. And finally, how many students like none of the three fruits? That is where this lesson is going to end. If there's any issue of concern, you can always let me know in the comment section. This is Hub Beyond Numbers, where we learn math the easy way. Stay tuned, and if this is your first time visiting this channel and then you think this channel will be of help to you, you can always choose to subscribe if you so do wish. See you, and then bye for now. Stay blessed.